We need to move to next one. It's another interesting topic, Dr. Ölmez. And then the title is Win-Win or Win-Lose Situation Assessment of Ship Recycling Sector of Turkey in terms of Green Marine Industry Approach. And checking. Our presenter hasn't arrived yet. What we can do, maybe we can move to, if I'm not mistaken, he's not in the participant list. Dr. Hasan Ölmez is not here, yes? Okay, so if he joins later, we can ask him to present as a last paper. In the meantime, I wanted to switch Dr. Nalan, Erol, and then Dr. Kamer and Dr. Çaylak. The title of their paper is A Look Through Autonomous Vessel. If they are ready, I think it's better you present. And then please give a brief introduction about yourself. Thank you very much.
Thank you. First of all, we are very happy being in this organization. I shall share my screen and then okay. Are you seeing the whole page?
Yes, we are seeing your presentation.
Okay, thank you. I'm Nalan Erol, working in Uzmar R&D department as a project leader, and today we prepared a presentation about autonomous vessels with my colleagues, Mr. Gökhan Kamer, our design manager, and Mr. Emre Çaylak, our business development executive. We will try to give brief information about these autonomous vessels. Here is the content of our presentation. We will give the definition of autonomy and why it is needed, and we will speak about the levels of autonomy, and then we will briefly give information about the current projects and the future projects, and then we will be speaking about the design part of these autonomous vessels, and mainly the software part, the technology behind and how it works. And then we will be giving information about the challenges, and then we will speak about our own autonomous project. Let's start with the ship autonomy. Ship automation systems permit individually and geographically diverse components to work together so that a plant can be monitored and controlled remotely. Here we would like to give the difference in unmanned and autonomous ships. In unmanned ships, it can be remote control. It is without the physical presence of a person on board. But when it is autonomous, it acts independently of people. These are the autonomy levels according to IMO. There are 4 degrees. Degree 1 is already reached. Ship with automated processes and decision support, seafarers are on board. When it comes to degree 2, it is remotely controlled ship with seafarers on board. When it is degree 3, it is again remotely controlled ship but without seafarers on board. And when it is fully autonomous, it is degree 4. Ship is able to navigate itself and making decisions itself. So why autonomy? Why do we work on these projects? Because it has many positive effects, such as reduced or eliminated need for human control, so decreasing the human errors. It provides longer duration performance, and there is improved reliability compared to remotely controlled unmanned vessels. There is the controllability and deployability enhancements. There is also reduced personnel costs. It enables extended operational capabilities. There is the reduced risk of piracy for both the crew members and the cargo. Increased available space, so more cargo place. and there are reduced design constraints, not having people on board, and removed need for a traditional navigation bridge. So it also has many design advantages too. Here is an image of Rolls-Royce Marine, how it is going to be, how we will reach the autonomous vessels. By the year 2025, it is thought that we will be seeing remote-controlled unmanned coastal vessels. And 10 years later, we will be seeing remote-controlled unmanned ocean-going ships. And by the year 2035, we will be seeing autonomous unmanned ocean-going ships. In current situation, there are both studies about the legacy part of it, the rules part of it, and the technical part of it. Here is the Maritime Safety Committee's studies on SOLAS, Colrec, load lines, training of seafarers, tonnage measurement, and special trade passenger ship instruments. And also there are very big conjoint projects of Kongsberg, the NVGL, Rolls-Royce, and EU. And on the other hand, there is a Japanese consortium working on autonomous boats, and Samsung Heavy Industries, Hyundai Heavy Industries are working on it. There is the CAS project. And there is an interesting point that up to now, there are 3,000 patents only in China, which are related to autonomous shipping technologies. What is changing? What is changing in a ship when it becomes autonomous? This is mostly related with the naval architecture part. For example, in hull structure, when a boat becomes autonomous, there will be closed structure, external access for maintenance and repair, and there will be streamlined exterior. So wind resistance will be reduced, and prevention of piracy for crew and cargo will be enabled. When it comes to deckhouse, there might not be a deckhouse even. Without accommodation for crew, no stairs and doors, no sanitary system, no galley and laundry. So there will be ship lightweight reduction. So it will be possible to load more cargo, and there will be a reduction of ballast due to reduced weight. In machinery, there will be no HVAC and life-sustaining systems. There will be small main and auxiliary engines and reduced electrical fuel consumption. We will see. When it comes to propulsion systems, mostly there will be electric hybrid propulsion systems, electric propulsors, DC grid system. So efficient electric power and reduced electrical consumption will be in use, and the efficient control of the equipment will be seen. When it comes to equipment-wise, there will be more hardware, software equipment on board, such as IR cameras, LIDAR, radar, high-resolution sonars, microphones, wind and pressure sensors, homogeneous and heterogeneous redundancy. And it will make us consider installation and integration of these all equipment, and there will be potential requirement for remote maintenance and inspection. When it comes to hull outfitting, there will be a need for fully or semi-automatic cargo handling and mooring systems, and there will be no life-saving equipment. So boarding crew for cargo handling and port calls, we will be seeing decrease of lighting and ventilation, modified dockside infrastructure, and electrical and fuel savings. So actually, there is a lot of change when we look at the subject and design-wise. How is this achieved? How a boat becomes autonomous? What it has to do and how? There are main 4 subtasks. These are object detection, object identification and recognition of the detected object, and then object localization and movement prediction. These are all done by GPS, radar, LIDAR, sonar, odometry, and inertial measurement units. Here is a DMVGL's prepared summary of an autonomous system working. First of all, we have our radars, IS camera, LIDAR, other sensors, which is in the condition detection part. They all go under sensor fusion and cross-verification, and the outcome is the detection of the object. Then comes the condition analysis. In a world model, the object is classified, and then its situation is analyzed. And it comes to the action planning, collision and grounding avoidance, and moving on. And there is the action control part, which is done by the control system, checking if everything is going well. And also, sorry, just to turn back, this sensor fusion and object detection, classification, and the action planning system are all done by a familiar word that we hear a lot, algorithm. What is an algorithm? Algorithm is a decision-making system that allows us to imitate a captain's brain. Let us briefly say, we hear there are lots of algorithms, as you might see in the image, from 1999 up to date, and more going on, starting with generic algorithm, A-star, velocity obstacles. There are machine learning methods, deep learning methods. There are neural network, as in reactive methods. How this algorithm works? Let me show by an example. Here is A-star algorithm, which is used in shipbuilding, in ships a lot. It's very simple, actually. It depends on avoiding obstacles, as you might see as a gray color here, and choosing the shortest path. I don't know if you could see my cursor, but mouse. When it is moving to the target of point 1 to 1, the A-star algorithm chooses the shortest path. It doesn't go from 4-2 to 4-3, but instead it goes to 3-3. And then it doesn't go to 3-2, but it goes to 2.2, this square. So this is basically how a simple algorithm works when it comes to decision making. Also, as I mentioned a little while ago, IMO said there are 4 degrees of autonomy levels, and degree 1 is already reached. In order to reach the other 3 levels, we need to work on the issues I will mention now, such as the regulatory framework, liability, cybersecurity, safety and navigation, reliability and maintenance, connectivity, and piracy. This is the general part of it. And there is another part of it when it comes to softwares and hardwares that are needed in autonomous shipping, autonomous ships. It is the real-time response, computational complexity, black box behavior, accuracy and reliability, safety, security, and IE, and ethics and IE. IE is artificial intelligence, sorry. So when it comes to UZMARS project, I'm coming to the end of my presentation, small by small. We are a group company. We have our pilotage company, we have a shipyard, and we have our technologies part, and we have delivered more than 150 vessels. These are our references. And we have our own R&D department now working on several projects, which is one of them is our ERP system, which is a first step of our digital shipyard. Another is O2's online situation control and plant maintenance system. We are also using VR for our design activities. And also we have a Horizon project, which has a instability helping system on board. When it comes to UZMARS autonomous project, it will look like this somehow. It will be capable of route mapping, decision making, data transfer, and call rec-based collision avoidance. Let me summarize its capabilities here in a table. It will be a small boat working in a bay and giving information, supplying information to our tugboats for easy maneuvering and easy pilotage work. The system will take into account the sea readiness check, voyage plan, weather check, path planning, unmooring, mooring, object detection and tracking, control and monitoring, alarming and decision-making, collision avoidance, emergency response, and failure diagnosis. We are at the very beginning of the project, so I am not able to give any more information about it, such as the main dimensions or the propulsion system, but soon we will be revealing those too. Thank you for listening. These are our references. And we would like to finish our presentation by saying the best way to predict the future is to create it. Thank you very much.
Thank you very much, Dr. Erol. Very interesting presentation, exciting project. And it's nice to see industry in the presentation as well, like the conference. In the end, we are all trying to do something that's really 3D structure and futuristic. Any question to Dr. Erol?
Yes, I have a question to Nalan, Erol, Nalan, Erol. The topic is very interesting, multidisciplinary. In the world, of course, there are, I cannot find the adjective about it. Hummalı deriz ya Türkçe'de. Very intensive works they are carrying out. As Uzmar, I think your team will further develop this project with the collaboration sorry, with the collaboration of universities, including Serkan's University and other. We are all ready. I think you will accomplish a successful project. So it's just a comment.
Thank you very much.
Thank you for your nice presentation. Okay.
I have a question. What do you think? What the industry needs from university to achieve this technology? Always we are getting comments that maybe projects are not ready for this. Do you think? Oh,
sorry, I couldn't hear your voice.
I noticed my internet is not good.
You asked what we need from
universities. Yeah, do you think we need more new programs to teach students this kind of technology, autonomous shipping, the ship systems, rather than classic naval architecture, marine engineering? Should we bring new topics to the, like the team you have? Are they mainly from naval architecture, marine engineering background, or they are electricians?
Okay, I think I understand your question. In our company, we have a separate technologies group, which are computer engineers and electronical engineers. So in the software part, and we here, Mr. Emre and Mr. Gökhan, we are all naval architects. And actually, we are working closely with the universities, with the electrical department of the universities. They are very open to projects, these kind of projects. But as you mentioned, it might be better to find more ways to combine the industry studies with the university studies. I may say by myself, it's far more better than now when I started working. And I would like to ask if Mr. Gökhan or Mr. Emre would like to add anything on this.
Hi, everybody. Let me add some words about that. Of course, this is a very multidisciplinary problem, and we are facing a lot of challenges as we try to describe in our presentation. and universities has a very important role, and we have very close relationship with the Maritime Faculty of Istanbul Technical University and all other departments from different universities, like Ms. Nalan said, electronic departments, software departments, and not only universities, also we are trying to create a network which we would like to implement the existing technologies in other industries like automobile industry, aviation industry, and so on. So this is not only related to naval architecture. This is very wide range of multidisciplinary, and it is very new technology actually, because when you look at the development of the artificial intelligence will be the core of this development, and this is very new in all the industry. So we need to be very close cooperation with wide range of stakeholders from the industry, institutes, research institutes, and universities as well. So we would like to be the coordinator and the front runner of the project, but we need a lot of support from universities. Also, I can maybe give you an example. There are also student teams in Istanbul Technical University. There are some international competitions for developing this artificial intelligence. We are supporting them. We are having a lot of meetings with them, and I think they will realize this. Not our generation. We are a young team, very young team, in the UZMA, in the R&D department, but this is not our generation's job. I think these young generations in universities, they are students now, and they will realize these autonomous vessels. We believe them very much.
Well, true, you are showing the future, and definitely the universities need industrial advisor like you, and they can actually choose their projects, and even the teaching program can change. Transport of Minister in UK announced what you are saying, and they are giving lots of funding to industry and the universities to change their structure. And this is actually very important, national, international wise. And definitely this step has to be done. And I congratulate Uzmar for doing this. It's very important because there's no guidelines. And everybody will look at this example, what you are doing, and it will be more important in the very near future. Then emission is important, human factor is important, decision making. Definitely, everything is smart technologies, and the ship has to be smart, and our students has to be smart. That's great to hear.
Thank you very much. We are very much excited, and we are glad that you are also excited.
Yeah, definitely. I will be one of the person following.
Thanks a lot.
Further questions? I'm trying to check.
If Mr. Kamer asks, I'm waiting for him. If I will add something, but maybe Kamer will say something. I don't know.
Thank you for this presentation to Ms. Nalan, and also for all the participants to this organization. It is good for us to be here and explain ourselves and to make the decision maker on these roles for the naval industry in Turkey. We, as a Uzmar shipyard, we believe that the autonomy will lead the future of this cargo handling, cargo transportation, and the many sections in the Navy, and also the maritime sections. So that's all our research and development department and all the organization will be prepared to this stage of this technology at this stage. As Nalan and Emre said, we have many good cooperation between the subcontractors, technology introducers, and also the universities and the class societies. You know, this technology is not related with the technologies, and also it is related with the legacies and rules and requirements of these maritime industry. We have a good contact with the class societies, especially in Turkey with the Turkish Lloyd and also the Breveritas. And also we have attended many autonomous tenders as a Uzmar shipyard all over the world between the different kind of the societies and the tenders owners. So as we said, if we have the good position in this role of the autonomy of the vessels inside the shipbuilding sections and all over the world, then we will be happy and it will be good for all industrial stakeholders, as universities, as suppliers, as class societies, as a Turkey. It will be at the end of the game good for all of us. We believe that. Thank you.
I will, with your permission, dear Chairman, I will add a few words. Thank you. Very interesting subject. Of course, it is an RTD project, multidisciplinary, and the collaboration is concerned with the universities, with the experts, class societies, so on. I should say very interesting conversion or attitude, I can say, of the universities. Now the students, Karadeniz Technical University, our university, my university, Yıldız Technical University, or ITU, Bursa, Bandırma, we are together now in the spring. There are colleagues from different universities, including Turkish Naval Academy of National Defense University. We are all together. We are like a cluster, research cluster of the universities with our technology transfer offices and technoparks. Now more entrepreneurship is active at the universities. So I know very well there are what we call it RTD divisions, authorized RTD divisions of the shipyards and other ship industry companies, authorized by the Ministry of Industry. More collaboration is needed to prepare, let's say, paper for this conference, for papers or other publications for other things, including journals. There were some papers arrived to this conference. I tried to connect and suggested some sections, some arrangements, so more collaboration is needed, briefly saying, more collaboration. We should express ourselves to abroad. This conference also aims it from Uzmar, from universities, from other industry students, from Croatia, from Britain, all. There will be, I hope there will be another special workshop or any symposium on these issues, because there is a big competition in the world. We are together always, I say this.
We are also open to any type of collaboration, of course.
Yeah.
We are passionate about maritime people. Although we are naval architects, we are in a shipping company, and it's as a part of a maritime company, we are passionate about our business. So all these technological developments, and we are, as I said before, we are very excited to be a part of this technological development, and hope to collaborate with all not only universities, other companies, other shipyards. We are open to work together.
And the university try to send students to the industry for short-term visits, for their project, for their completion project, or as training, compulsory training. So more interactions with the Technopark zone. There are more interactions.
We will try our best, and I can also announce here that our board's decision is to create Turkey's first autonomous shipping laboratory. So we would like to. It is not definitely defined yet, but the target is over there, and Uzmar is willing to create the Turkey's first autonomous research centers. We are discussing with the universities and other software developers, and hope we will be taking a position.
For the prototype operation, I think Sapanca Lake will be very interesting for you, or something similar.
Yeah. For the prototype, yes, but that will be a research laboratory, not only for the vessel itself. We will be doing simulations and training of the maritime students for the future autonomous shipping. So that's a huge project. We will be sharing the details with the industry very soon.
What a nice, çok güzel.
That's great news. Thank you.
Great
We all
things.
need data.
Sorry, I think we take a lot of time.
No, that's actually we are perfectly on time, I believe, because also we don't have two papers, so there's no problem. I'm just checking. I think it's better to close the session. Hard to say because it's quite interesting, but thank you very much for Dr. Erol's presentation and the Uzmar team, Mr. Kamer and Mr. Çaylak, for their great contribution, and thank you for the other presenters. And then we are closing this section. There are more coming, and then see you in the future. Have a great afternoon. Bye-bye.
Thank you.
Bye.